Hello team, today's challenge is Frontmatter Parser, where we're given a chunk of front matter with the dashes in front and behind, and we're expected to parse out the keys and values into an object. And the important part of this is that everything inside of this front matter block will be a string, but we need certain things like the booleans to actually be booleans and the numbers to actually be numbers. We're going to have to figure all that stuff out. There's also an extra bit in here where they only ever give us front matter today, so it starts and ends with dashes every single time. But what happens if they send through the body as well? Or what happens if they send through only the body, right? There's some questions in there that we can take care of as well. So to do that, I'm going to jump over here and I'm going to create two regular expressions. One is going to be to test that we only have the front matter, okay? And then the other one is going to be how we get those keys and values out. So right here, I'm going to go const. This is going to be front matter block regular expression. Okay. This is going to be over here, and we go what? Well, we start with dash dash dash, then a return, then anything, then another return, then dash dash dash. Okay, that's the whole regular expression. We do want to be able to capture this middle part, so let's wrap that up just like this. Excellent. There's a problem in here in that the dot operator will not capture new lines. And if we capture everything inside of here, so here's the dash 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 with the return on the end, so we capture everything to this, but not including that final return, right? And there are two other returns in there. Could we split on those and then split on the colons? Yes, but we can get that done a little bit differently, okay? And so to do that, we just want to keep this block. And the easiest way to do that is with the S flag, okay? The S flag is not used that often, but what it does is it allows you to capture new lines with the dot. It translates to something called the dot all flag, which means that this dot will capture special characters like new lines as well, okay? Which means that we get everything in there, and we get it first as a match, right? The match will come through. It'll be an array where we get the match, and then array index 1 will be our capture group, okay? The second regular expression is the keys and values. So let's just call this keys regular expression. We're going to set it up as the start and end, okay? Now, how do we get the start and end on a string that has returns, right? Well, we do that with the multiline, okay? Multiline will change the way that these characters work to be the start and end of a line, not including a return. So we'll have these three lines here. The start will be here, the end will be here, start will be here, end will be after full, start will be before views, end will be after 100. In order to make sure that actually happens, we need this to be global. Okay, so global multi-line, and we can tuck into this and do it. I also spelled this wrong. Let's do that really fast. That's why it's screaming. But the regular expression works like this. We get our whatever our characters are, followed by a colon and a space. It is guaranteed to be a space, but what I like to do is I like to ensure that it is any sort of white space. Okay. In fact, if you wanted to, you could set it to 0 or more white spaces, right? So options there. I'm going to leave it as plus for today, but right here, I'm going to grab my second capture group, which is the everything that's after. So we have the key, the colon and space, and the value. And because we capture these, we're going to be able to work with them directly, right? So we'll just pull them out of the match object, right? The match array, iterable, whatever you want to call it, the regular expression match, and we can get that done, okay? So right here, we have matches, okay? Matches is going to be our string, which means that we can match on that FM block regular expression, okay? FM block regular expression, I mentioned this before, but it's going to return an array which has the whole match as index 0 and the capture group as index 1. We only really care about index 1, so let's peel that off, okay? And then right here we do match all. And we need match all on this one, because if you use match with a global flag, it will only return an array of full matches, okay? So our capture groups will just go into the wind, right? They'll just be gone. But with match all, it returns something that is like this first one, where we'll get not an array, an iterable that has a bunch of arrays with the full match and the capture groups just like that first, okay? So match all is where we want to live, which means that we reach in here and go fm keys regular expression, okay? From there we can set this up. So let's set output equal to an object, and for let match of matches, just like this. Sending it down, we can grab that that information from each. So let an array, right? We don't care about that first match, so we just skip it with the comma, right? If we don't give a name to this, then it will ignore it. It'll just blast it into null, okay? So from there we have the second one, which is our key. That's our capture group, and our value. We can space these or not. I'm going to space them because it looks nicer, but we get that from match, okay? Here is where we do a little extra work to change this, okay? So this value, we want to do something with that. I don't want to do that inside of this for loop. Instead, I want to bump that up to its own function. So I'm going to go function coerce to natural, which is probably a terrible name, but here we go, just like that, okay? Now, testing if it's a number. If number.is nan, capitalizing the right ends, okay? And we could send in plus value. Now, if this is a nan, right, then this would be true. We want it to not be a nan. So let's do this, flipping it around. And then if that's true, it's a number, which means that we can return value with a plus sign. Sorry, we need to return it as a number, right? True or false? Let's do true or false. So if a regular expression with true or false, okay, we're going to test our value, and if that's true, then we return the Boolean form of this. How do we get there? Well, we return value triple equals true, right? So if the value is equal to true, this will evaluate to the Boolean true and return. If the value is not equal to true, well, then it must be false because that's what our test did, at which point it will return the Boolean version of false. So excellent. Very simple, very easy to get around. The last thing is to return value, because if it gets through these two conditionals, then it must be a string. At least that's the hope, right? And we could build into this for things like objects and stuff like that. We're not going to do that today. We're just going to keep it simple. But there it is, okay? So coerce to natural, we're going to use that right down here. You'll notice that I used a let. So I'm able to go value, just like this, equal to coerce to natural value. And then, of course, output, not dot, but a square brackets, so that we can go key equals value, okay? Last step is to change this. So output, just like this, and it works, okay? In fact, because we were guaranteed to get a Frontmatter object today, we don't actually need this first one, right? I included that in there so that I could teach the S flag, the .all flag a little bit, but we don't need that. But I still think that it's useful, and here's why. Over here, I've taken my code. There's some comments in here, but this is the same code. So I still have coerce to natural. I still have parse Frontmatter, and if I run this, it seems to be screaming, but my tests, which I didn't show, right? I have this bit here where there's something in there, okay? It is just the Frontmatter, just like we had. The second one is the Frontmatter with some body text. The third one is just body text, and there's a strange key value thing going on in here, okay? So with that test, we're failing. And we're failing on this last one because there is no front matter, right? It still works on this because of how we're getting stuff, but it doesn't work on the other things because right here, this one doesn't exist on match. Match returns undefined. There is no one, so we need, what do we need? Well, we need optional chaining, okay? That's going to change this. We can clear this out. We can run it again. And we should get a different error, which is matches is not iterable. Well, that makes sense because if this doesn't exist, it drops undefined into matches, which, I mean, there's no way to iterate over undefined. So we need something more. What do? Well, in this case, we use nullish coalescing, which is the question marks and an empty array. At which point now, if we run this, everything should run and we get that empty object. Brilliant. So we can bring this back over, right? We can totally do that right here. That was this block where we had the optional chaining, just like that. And this part with the nullish coalescing, just like that. And everything should still work. Okay. I feel like this is a solid start, right? There's always other stuff going on with Frontmatter. There are arrays and stuff like that we'd have to take care of, but as a way of guaranteeing or giving us a solid way to start this project, it feels pretty solid. And it let us ensure that what we're getting is exactly what we expect, right? Without just breaking everywhere. So fun times. On that note, this is it. Again, not every solution, just hopefully one good solution. Did you like it? Did you hate it? Did you go a different way? Let me know all that stuff in the comments. Otherwise, today this has been Frontmatter Parser, and I will see you in the next one.